socially distanced from all of you, as well as all those people in Wuhan. Of course, I'm not there at all. I really happen to be somewhere much more beautiful. Anybody know where I really am? Of course, I'm going to take off this nasty mask thing, and now you can see me. And actually, I don't really need this either. Ladies and gentlemen, I've had a beard for years and years and years. I don't have one anymore. I'm going to explain to you a little bit about why I haven't got a beard and what's that got to do with coronavirus. But I'll tell you a few other things as well while we go about it. So let's just start with beards and face masks, shall we? So the first question I want to just touch on is, what do you do when you have extra time available to you and you're not traveling to work 2 hours a day in and out of central London? Well, clearly, for the first time in 25 years, have had time to watch a little bit of Netflix, and Stissel has really been there. And I've been thinking about whether it's right for the men in Stissel to have a beard. Should they grow it? Should they indeed keep it? So why have I got rid of mine? Well, the simple reason is because that I have to do aerosol generating procedures when I do endoscopy as a gastroenterologist, and I have to wear these rather nasty masks, which filter out 99% of all aerosols, and they have a very low leak rate around the edges. And then you have to be formally fit tested to make sure that the masks fit you. Now, if you look at this Purim photograph from some years ago, it's not great to wear a mask like this, and even with a beard like this, it's not a great idea. And in fact, the Center for Disease Control in the United States of America some years ago did a piece of research looking at different beard styles, working out how much leakage there was. And somebody who had a full beard like I did would have anywhere between 20 and 1,000 times more air leakage around the mask than someone who had a Zappa moustache. And so I decided the obvious thing to do was to get myself a Zappa moustache. What's that? My picture's not coming up. Oh, that's really sad. Am I not sharing my screen? My wife's telling me I'm not sharing my screen.
It's good. It's good.
It's really sad. I want to share. I want to share my screen because that was a. So I wanted to have a Zappa moustache, ladies and gentlemen. There's the Zappa moustache that I used to have, unfortunately, my wife didn't like the Zappa moustache, so I've got rid of it. Do these face mask things work? Well, these are the sort of the homemade ones that people are making themselves, and these are the ones that the doctors wear in the hospitals. This is a piece of work that was published about 3-4 years ago, looking at sort of, there's actually a time, it's cotton handkerchief, but it's very much the same as these cotton masks that you're being encouraged to make by yourselves. They block about 30% of particles, whereas these very simple surgical masks actually block, it's this one here, blocks about 80% of particles, and the respirator mask that I'm using is at 99%. And we need really tiny particles to be blocked, because the really tiny particles are the ones that carry the viruses, although clearly they come within bigger droplets as well. So I just want to show you what a face mask actually looks like. Before I do, and this was quite an interesting piece of work published about 10 years ago. So this is with a standard surgical face mask. This is with a respirator face mask. And this person's coughing. And with a surgical face mask, you can see all the white stuff, gray stuff. That's all the particles from the cough going around the side of the face mask. Whereas if they're wearing a respirator, rather less stuff comes out. So if you look at a face mask, you will see that it actually has 3 layers. I'll cut my face mask and you see it's got 3 layers. The front layer is the blue layer everybody's used to. The middle layer is actually a white layer, and this white layer is made of polypropylene, and this is what filters out the viruses. And so there is some extra benefit for wearing these single-use devices. In any case, it's just over 3 months ago now that the World Health Organization announced that there was a coronavirus pandemic. Of course, as everybody knows, it first appeared supposedly at the end of December, although increasing evidence is suggesting, there's some fascinating actually evidence looking at the use of car parks in Wuhan. Some Americans did some snooping data and realized the car park usage was going up in October, November time. There seemed to be increasing activity. So the suggestion was actually it appeared much earlier than people gave it credit for, but who knows? So let me just share my screen again. This time I really will share my screen. You missed the fun bit before, never mind. So the total cases of COVID-19 by country. And this is a ranking. You can get this on Google, and you can see the USA has the highest number of total cases. UK is 5th in the whole world. You need to correct that for the size of the population. India, interestingly, India's got 1.4 billion people, but has only just got slightly more cases than the UK. But we'll come back to that in a minute. And then if you look at the total deaths, well, unfortunately, UK is still doing pretty well. It's right up at the top. Third highest number of deaths, at least that we know about. These numbers are going to change, of course, because some countries don't report quite as well as others. But if you look at the number of current active cases, the UK is not anywhere in the top 20. And this is a rather important feature that we need to, we need to think about. So if you look at the daily number of cases that have been happening of COVID over the last 3 months, there was a huge peak. We locked down at the end of March. The number of cases rose very dramatically and then sort of stabilized and then been sort of slowly falling off. And this is in the UK. And the number of deaths similarly went up and then have been going back down again. And that certainly mirrors the experience that I and all other doctors have noticed in our hospitals in London. But interestingly, I just pulled these data off today. You can see the trend, number of new cases per day falling. And you notice at that point, there was a couple of weeks ago, that was the lowest number. We haven't quite been at that number the last couple of weeks. And I just wonder whether we're going to start to see the cases starting to rise. And this is not funny, because if you look at the whole world, this is the number of new cases per day across the world. And we think we've cracked it in the UK and in Europe, but I'm afraid worldwide, that is not the story. The number of cases is going up and is increasingly going up faster and faster. And I'll give you some examples. This is India. I was talking to a colleague of mine about 4 or 5 days ago, and he's in India at the moment, and he said to me, and his words were, "It is carnage." That is what he said to me. And I was talking to a colleague of mine from South Africa on Friday, and she was saying to me, well, we know in the Western Cape, that's Cape Town and sort of to the west in South Africa, the numbers are already very high. She said, are sitting in Joburg, and we know that we're going to get the peak in about 8 weeks' time. And remember, all of these countries locked down at the same time we did, and then they released their lockdown. And actually, whereas we released our lockdown after we'd already had large numbers of cases, they had no cases. And everybody's saying, oh, you're doing really well. But they've released their lockdown now. They've already had the economic damage, and now the numbers are going up. Ladies and gentlemen, there's some pretty nasty times coming ahead, I'm afraid. And just to sort of to remind you that just what it could look like, this is Israel. It had a peak at the same time we did. Everything fell. They started unlocking a few weeks ago. Numbers of cases are now steadily starting to rise. Okay, let's start talking about things like R numbers. So everybody's heard of the R number, the average number of people infected by one infected individual. By the way, if you want it in your chat, if you'd like to say what country you think I'm in, I'm going to change country now. So I'd quite like people in the chat to put what countries they think I've been in. So the R number that you've heard lots about. If the R number is greater than one person will infect more than one other person, then the epidemic will grow. The R number for COVID-19 appears to be in the region of 3, which is pretty high. One person will infect around 3 others. If the R number is less than 1, then the epidemic will decrease.
You're not sharing again, Laurence. Do you need to be sharing?
No, I don't. I want you to see me. Can you see the beautiful background?
Yeah.
Where am I? That's the question. Nobody's put it in the chat yet. Please, will you guess which country I'm in? And so, traditional test approaches, and you've heard this all in the news. Test, trace, isolate. Yeah, test everyone with symptoms, and we're still waiting. I mean, our testing system seems to be getting up and running, but it's not quite there yet. Tracing everyone that's been in close contact with other people. South Korea is doing it really well. The UK trailing a little bit. And then isolating anyone with symptoms and anyone who tests positive. These are the ideas that we really need to get under our belt. When you think about the R number, you need to think about the dots, joining the dots. D for duration, how long a person is infectious for. So it turns out that the peak infectivity is probably a day or 2 before a person becomes symptomatic. And so something like 50% of infections are passed on from one person to another when the person who's passing on didn't even know they were infectious. So that's the D for dots. The O in dots is opportunities. How many interactions the person has when they're infectious. So if you think about just before the lockdown, we had Purim. And Purim, everybody's in shul. Of course, it's also a big time for weddings. And sadly, a lot of people became sick. And then, of course, you have the funerals. And funerals are a great place for people to meet all together. And these are all bad for opportunities, and hence the importance of the lockdown. There's the O in the dots. What's the T? Is the probability of transmission. The social distancing, if you keep people 2 meters apart, there's less transmission than 1 meter apart. If they're meeting outside, it's safer than being inside. If they wear that wonderful broken face mask, they will reduce the amount of fluid droplets being transmitted. So my face mask will protect you. It doesn't really protect me all that much. It protects me a bit, as I've shown you. But actually, my face mask will protect you because my droplets don't get to you. The worry about wearing a face mask was that if you wear a face mask and you think, oh, I'm protected, you then go nearer to the person than you otherwise would, and then you actually potentially reduced the safety that you've got by wearing a face mask. So there's a balancing act here, and this is something that we've been troubled by for some months. The government have finally decided actually face masks are better than no face mask. And the S in the dots, see the duration, how long you're infectious for, the opportunities to interact, the probability of transmission when you interact, and S is the susceptibility of the person being exposed to infectious disease. And we know that older people are more susceptible, people who have high blood pressure, diabetes, etc. So these are also the epidemiological things we need to think about. So if we could test everybody, imagine testing the entire population once a week and knowing on the same day that whether somebody was infectious or not, you could then have a really targeted way of saying, you've got to stay at home for the next week or 2 weeks, and you can go to work. And actually that might be a way out of it. But it's not entirely straightforward. And one of the things people were hoping for was that the antibody test would be the answer. If you have the antibodies, you're immune. So unfortunately, I have a son who is a junior doctor. He was working on a COVID ward for 3 months every single day. He was ill for a while, as was I. He's had himself tested and is antibody negative, which is very odd because it's almost certain he's had COVID. And it turns out, and there are now quite a lot of reports coming out, that the antibody tests go negative, even if they were positive, in people who had relatively mild disease, and young people have relatively mild disease. And it also goes negative even in people who had more severe disease after about 2 to 3 months. We don't know what that means for immunity yet, but we do know that the antibody tests are not going to be hugely reliable. And so that creates more troubles for us. Now, I am going to share my screen again. And this time I want to talk to you about potential scenarios for the pandemic and how it's going to develop. So this was some modeling that was done by some colleagues of mine, looking at different ways that the pandemic may play out. So we've had a peak of cases, we're now down in the trough, and it could be we have peak after peak after peak until we get to about 2/3 of the population have been infected, at which point the peaks will sort of peter out. And you will get the so-called herd immunity. That's one scenario. A second scenario, however, is what happened in the Spanish flu of 1918 to 19. There was an initial peak, which was actually in the summer of 1918. And then there was an almighty peak in the winter of 1819. And that was when between 30 and 50 million people died. And there were a couple more peaks and then eventually petered out. There is a third possibility, and that is you had your big peak, and then you're able to manage it so you have sort of a slow burn until everybody has been infected or we've got a successful treatment. Now, so I need to tell you a little bit about pandemics. By the way, I noticed we've had Switzerland, New Zealand, and Norway. So most they're all wrong. Let's try a different country, shall we? Let's try that one. Okay. So a little bit about pandemics, ladies and gentlemen. 1997, the H5N1 bird flu, SARS 2002, MERS, Middle Eastern Respiratory Syndrome 2012, 2008 to 9, the H1N1 swine flu killed more than 250,000 people, Ebola in West Africa in the last few years, the Spanish flu I mentioned to you in 1918, it killed about 50 million. How many people have died from HIV? Anybody know? I'll give you 30 seconds to put it in the chat, and I'll give you 10 seconds to put it in the chat. Anybody want to guess how many people have died from HIV in the last 35, 40 years? It appeared in 81, 82. Nobody's put it in the chat. the number who died from HIV, 5 million, somebody's put, is actually between 30 and 50 million. Huge numbers of people have died, but we didn't realize it because they've died in Africa. But interestingly, many diseases that we all recognize started as some form of transmission from animal to human. Smallpox entered humanity at least 5,000 years ago. Measles started, the first description of measles actually is about 1,000 years ago. And so we need to think about three words: epidemics, pandemics, and endemic. So smallpox, which started many eons ago, is of course endemic. It was regularly found amongst particular people in a certain area and went on and on and on and on until we finally eradicated it about 30 years ago. Measles started as an epidemic. There was a widespread occurrence of an infectious disease in a community at a particular time. And indeed, measles, a measles epidemic in America, when the Europeans went to explore the New World, probably decimated the native populations. And interestingly, there was a mini ice age in Northern Europe in the early 17th century. And some recent work has suggested that what actually happened was that the Amazon was not native forest, but in fact was very well developed by the native populations as they died out in the 1600s. So the Amazon all regrew, and that cooled Northern Europe by about 1 degree, which led to this mini ice age. Absolutely fascinating, particularly as we're going exactly the opposite direction now. So epidemics, endemics, and pandemics. Pandemics are epidemics, widespread occurrence that goes everywhere, which is what this one is. But interestingly, pandemics then can change to become endemic. And indeed, there's a common cold virus that many of us get, which has been, its origins have been traced back to a pandemic in the 19th century. It was an epidemic in Russia, which spread beyond Russia, but it's lost in history. It was around the time of the Crimea War. But they've managed to, recently, the scientists managed to trace it back and show that this endemic common cold actually was a pandemic originally, and that this may happen with COVID-19. I probably should point out to you that the vast majority of people with COVID-19 get a very mild illness. And the younger you are, the milder it is. We now know from a number of studies that people under the age of 30, more than half of them will have no symptoms whatsoever. However, as you get older, the symptoms get more severe, and something like 15% of people will get severe disease and 5% will become critically ill with the disease. And as we've said earlier, there are particular demographics: elderly, people with high blood pressure, diabetes, other illnesses, but also people doing particular jobs. I told you about the dots. You have to have the opportunity to pick up the illness. Who works in a situation where they're most at risk? The key workers, particularly healthcare workers. And it turns out that the Black, Asian, minority ethnic healthcare workers are the ones at the highest risk of the lot. And in some cases, up to 25% from getting really sick. And these are very worrying statistics. And of course, as I think you've all worked out, until a couple of weeks ago, until last week, in fact, there was no proven prevention or treatment, and there still really isn't much in the way of prevention or treatment. I'm going to go run through all this sort of stuff with you now. So did anybody get Cape Town, the best place in the world? They certainly did. So let me just get to your next country. Here's my next country. Now, nobody's going to get this one, but you'll laugh when I tell you what it is later. So I want to talk to you a little bit about the virus while you're thinking about what country I could possibly be in. Let's just show you the virus. So a virus is a very interesting thing. It's not clear whether it's alive or dead. So a virus has a membrane, it has a coat, and the coronavirus is called corona because it has these little crowns. It's the so-called spike glycoproteins. And the envelope actually contains RNA. RNA is the genetic material, which is then going to make more viruses. Now, human beings do not have RNA, we have DNA. but we then transcribe our DNA to RNA, and the RNA is then translated using our cellular machinery to make all the proteins, including things like, we don't have spike glycoproteins, but similar sorts of things, structural proteins and non-structural proteins, proteins that are used to make to enzymes that do jobs. And what the virus is going to do is going to get into our cells, and it's then going to hijack our machinery to its own ends to make more of the same. Now, everybody's fascinated about the concept of getting the coronavirus vaccine. And it turns out that over the last 20 years, really since SARS came along, and we had a near miss at that point, luckily SARS didn't turn into a pandemic in 2002, 2003, but it did really hit Southeast Asia very badly. There's been an awful lot of work on developing vaccines. And the idea of a vaccine is that you want the person's own immune system to already recognize something from the virus. So it will either be a bit of the RNA or be a protein, for example, the spike proteins, and will make an immune response so that when the virus actually hits, you immediately get in there and you stop the virus making you sick. And you can do this by injecting viruses. So you wouldn't inject the coronavirus itself, that'd be a silly thing to do. Or you could inject the coronavirus, but have mutated RNA, or you could have another virus, for example, a simian, a monkey-type virus that it normally infects monkeys, but actually will infect humans, and has been you put some of the coronavirus RNA into it, so that it makes spike glycoproteins, but nothing else. And that is what the Oxford vaccine is doing. And there are various other things, and it turns out that from the left side of my screen to the right side, they become less and less and less effective. But in fact, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 11 different approaches that are being used to creating vaccines. And this is a few weeks old now, but there were almost 60 different vaccines. The exploratory work had been done, another 30 odd, 40 odd where there was exploratory work that wasn't quite finished, preclinical phase before going into humans, so you're doing it in animals, and then a few in phase 1. We are now into phase 2 with the Oxford vaccine. I tried to sign up my hospital at UCH. They're trying to offer this vaccine to healthcare workers because we're at the highest risk. And I tried to sign up, and I'm a bit old, so they didn't want to give it to me yet, which is an interesting thing because the older you are, the less likely you are to respond to the vaccine, which is a bit of an issue because the older you are, the higher the risk of you getting severe disease. Okay, not great. And this is something that we have to think about as we go forward. So let me just talk you through the disease. Person's exposed, they get infected on day 0. It takes about a week before they realize they've been infected while the virus is quietly is multiplying itself inside the body. They get a fever and a cough, and then it resolves about 7 days later. That's the majority of people. However, some people get other symptoms. Everybody now knows about the loss of taste and smell, but there are all sorts of weird other symptoms people can get. And as I told you, particularly young people, even older people, may have no symptoms at all. So that's the standard approach, and that's your 80% of the population. But it's always the 80-20 rule. What happens to the 20%? Well, unfortunately, 7 days after getting the fever and cough, they've been bumbling along, they seem fine, and then suddenly, whoosh, the body, the immune response kicks in, and they get what's called the cytokine storm, which causes the body to have this enormous immune response. And that's actually what makes people very sick. And you will all have come across people, I suspect, who said, I was really ill, I felt terrible, I couldn't breathe properly, but actually I stayed at home and I got better. And those people had a cytokine storm. Unfortunately, in some people, the breathing gets so bad, they need some sort of breathing support. And one of the early trials was comparing ventilation to the CPAP machines. And you remember the CPAP is the mask that you put on people's faces to help them breathe. And actually, my hospital refused to take part in that trial because very, very quickly it became obvious that you want to give everybody CPAP and avoid ventilation if you could, because once they were ventilated, it was really hard to get them off the ventilators, and that's what we've seen since then. But people are getting breathing support. They will often get better, but will need further rehabilitation because it's been a pretty tough time they've been through. Some people end up with multi-organ failure. Again, after 6, 8, 10, 12 weeks, you've read some of this stuff in the newspaper and they get better. And sadly, a small proportion of people die. So if you think about trials, you can really put them into 3 areas. One is prophylaxis, trying to stop people getting ill in the first place. 2 is treating early disease, trying to treat it when it's acceptable, you know, you're not in hospital yet. And 3 is trying to cure and support people who are in hospital and who are pretty sick. Why do we do clinical trials, ladies and gentlemen? This gentleman, more than any, has caused quite a lot of, what's the polite way of putting it, trouble in the last few months. So on the 21st of March, President Trump sent this tweet: hydroxychloroquine and azithromycin taken together have a real chance to be one of the biggest game changers in the history of medicine. The FDA has moved mountains. Thank you. Hopefully they will both work. Anyway, it turned out that if you put those 2 drugs together, you kill people. That was the reality. In fact, we had to stop using these 2 drugs together. Not only that, but I'll tell you more about hydroxychloroquine as we go along. And just remember hydroxychloroquine, chloroquine, hydroxychloroquine. You're going to hear a bit more about it as I continue. Did anybody work out what country I'm in? Lanzarote, no, it's not Lanzarote. It's a country on the west of Africa. Keep going. So why do we do clinical trials? Well, because only a randomized trial where you're comparing X versus Y will allow you to tell whether the benefits of X are greater than the benefits of Y, and also exceed the harms that X is causing. You need to do this in a very rigorous way. And so what you do is you flip a coin and you randomize people to 2 groups. Ideally, you want people to be blind to what treatment they're taking, so they don't actually know what they're taking, so there's no bias involved. And you have really powerful data monitoring and a safety board, which is keeping a close eye on your trial. And all trials are set up in that way. So you probably all have heard now of remdesivir. Remdesivir was an experimental drug developed for treatment of HIV. It was then tried in Ebola. It was shown to be safe, but not terribly effective. And then until April, everybody's saying, oh, this is going to be the most promising antiviral drug for COVID-19. In April, a paper was published by accident on the World Health Organization's website, which suggested that remdesivir didn't work. But it was very rapidly removed, and there was a whole stir in the scientific community, but we moved on because there was a trial going on of remdesivir in hospitalized patients to see whether it would improve the time to recovery. It was US-led, it was an international trial, 100 hospitals were involved, with over 1,000 patients with advanced COVID, so who were already on breathing support. And they were randomized, flipped the coin between remdesivir and placebo, a sugar pill. And there was an independent data and safety monitoring board who met in April, and one of my colleagues who actually lives in Hendon is on that board, Professor Peter Sassini, and he told me and other people the story, that the number of deaths and serious events they have to consider. And there have been some concerns because there have been some nasty events happening. And so there was a decision by the Data Safety Monitoring Committee to check what was going on. And it turned out the patients on remdesivir were actually more likely to recover and less likely to die. And because of that, it was decided to be unethical to continue using a placebo. The problem was, at the point they stopped the study, they worked out that remdesivir meant that you spent less time on a ventilator, but they didn't have the power in the study to be absolutely certain that remdesivir decreased the likelihood of dying. So remdesivir is now approved for use, and it rapidly went through approval process, but that was on the basis of the fact that it shortened the duration of ventilation, not because it was proven to save lives and stop people dying. I'll tell you the steroid story in a minute, because of course that's another one you'll have heard about in the last week. But now I want to just show you the pathway. So this is a bit of a horrible slide, but I've been working on this for the last few days, and it's completely ingrained in me. So here is a SARS-CoV-2 virus, and this nice, beautiful blue sea area, that is a human cell. The SARS-CoV-2 virus, which causes COVID-19, attaches itself using 2 receptors, the ACE2 receptor, people may have heard of ACE inhibitors, they're used for blood pressure, and ARBs are angiotensin receptor blockers, also used for blood pressure, and everybody's worried because the ACE2 receptor is part of the process by which SARS-CoV-2, the virus causing COVID-19, gets into cells. There's another thing called TMPRSS2, it's another surface molecule which enables the SARS-CoV-2 to get into the cell. Once the virus is in the cell, it gets uncoated, the outer sheath gets taken off, so all those nice little spike glycoproteins disappear, and then out pops the RNA, which is now going to start making proteins. It starts on making some proteins, but those proteins don't do anything. And then it needs proteolysis, which is a proteases to chop these big proteins into little proteins, and these little proteins, non-structural proteins, they are the enzymes that allow the RNA to be further multiplied. And then you need these RNA-dependent RNA polymerases, and these are particular molecules that only RNA viruses have. Humans don't have them. So you can hit this area really hard, and you won't do any harm to any human beings, whereas hitting any of the other areas, you may cause trouble to human beings. Once you've got lots and lots of RNA being made and all the proteins to make the new viruses, you have an assembly. The virus hijacks the cell's assembly mechanism and out pops the virus. Once the virus is out in the circulation, you get enough of them. The macrophages, this is the immune system, starts recognizing, and the immune system starts sending out these cytokines, the inflammatory markers, which to try and gobble up these cells. And sometimes it works and sometimes it doesn't work. And you can see here, there's a whole series of drugs that are named, which work at all these different areas. It's not quite so simple, but it's a nice way of understanding it. You notice that chloroquine and hydroxychloroquine work at the stage of stopping the virus from uncoating, so the RNA can start reproducing. You can notice, however, remdesivir is working at the RNA-dependent RNA polymerase, the step that only the virus has, which humans don't have. And we've said that remdesivir is rather useful. Steroids work out here in this inflammatory environment. It's not listed, but there's one called tocilizumab, which is a very, very specific one, but actually steroids work in this sort of general milieu. Okay, that's complicated, and I'm sorry for doing that to you, but you'll see why in a minute, I hope. Does anybody get the country? Togo, Ghana. Well done, whoever got Ghana, that's very good. Very, very impressive. Okay, next country. So, we've learned a lot of lessons in the last 30 years. And I mentioned the HIV epidemic. 30 to 50 million people died. But it took us almost 30 years to turn HIV from a horrible, I mean, when I was a medical student, I saw people with the most horrible, horrible, nasty diseases and who died within a year. And we have no treatment. Now, HIV is a sort of, you know, you take your protease inhibitors, you take your RNA-dependent RNA, what's it called? The last one I showed, the RDRP drug, and your HIV is under complete control. The same principle was applied to hepatitis C. People may remember hepatitis C was sort of the non-A, non-B hepatitis that caused people to become jaundiced after blood transfusions. It became a scourge of the early years I was in gastroenterology. Now, a pill a day for 8 weeks and it's done, because it turns out that using protease inhibitors plus the RNA-dependent polymerase inhibitors sort it. And the question is whether we can do something similar with COVID-19. So, we mentioned randomized controlled trials. There are some trials going on, and there are some very, very big trials going on. The Solidarity trial is a platform randomized controlled trial which is being run by the World Health Organization. And if you notice, it's got a series of arms. Remdesivir, you've heard that one. Lopinavir, ritonavir is actually a protease inhibitor. Interferon beta is a sort of general anti-inflammatory, a bit like steroids, and chloroquine, hydroxychloroquine about uncoating. There's a UK version of Solidarity trial, and it's called the Recovery trial. And Recovery, very similar platform, use lopinavir, ritonavir, an HIV drug, which is a protease inhibitor, but also used dexamethasone, low-dose corticosteroids. And as you, of course, all now know, after enrolling 12,000 people in the UK, it turned out the corticosteroids have been successful. The lopinavir, ritonavir, the protease inhibitor alone doesn't look yet like it's going to be successful, but we don't yet know. So the steroids, as a general anti-inflammatory, seem to have been successful, but only in people who have got the most severe disease. It doesn't work early on. And so it's all very well if you're in the ITU on a ventilator and you're very sick, the risk of dying now falls from 50% by a third to 33%. But that's not really where you want to be. We want to be trying to stop it earlier. So it turns out that there's some very, very big players in this field. The Bill and Melinda Gates Foundation. By the way, yeah, it is Victoria Falls, and it indeed is, one side is Zambia, the other side is Zimbabwe. Well done to people who got it. So there are big players in this field. There is something called the COVID-19 Therapeutics Accelerator, which is run by the Bill and Melinda Gates Foundation and with the Wellcome Trust, together with MasterCard. And they've come up with this idea of trying to work on testing, treating, and prevention. And they put together for the treatment, this Therapeutics Accelerator, $125 million fund, which people like I could apply to, and we did indeed apply to them, and we did indeed win quite a few $1 million to do a trial, which I'll tell you about in a minute. So, treatments in hospital. I sit on a research committee in my hospital, University College Hospital. We take part in treatment trials. We're looking at all sorts of new drugs. I won't bore you with the details, but there are loads and loads and loads of drugs that we keep coming up with. And the real issue, however, is that we want to try and stop people getting sick. We want to protect the NHS staff. We want to protect the care home staff. And eventually we want to protect you. How are we going to do that? What sort of drugs can we use? Well, we need to have a safe drug. It's got to have rare serious side effects. Common side effects are very manageable and temporary. And the quickest way of doing this is to try and repurpose a drug that's been used for something else. We really want to be able to avoid people having to come to hospital. So you have to have a completely remote clinical trial, the whole thing done electronically, and you want to get your results done within a couple of months. And that was what the trial we set up. And the trial we set up was called the Crown Coronation Trial. And the original name, the Crown Coronation Trial, was Chloroquine Repurposing to Healthcare Workers for Novel Coronavirus Prevention. And therein lies a rather sad story, because the whole story about chloroquine being successful is based on a couple of small studies from China and France, which came out in March and which President Trump got all excited about. But since then, more studies have come out. And although chloroquine is probably one of the most widely used drugs in the whole world as an anti-malarial, and it's been around for almost 90 years, it turns out that although, in fact, very, very safe, notwithstanding everything you've heard, and I won't bore you with the details, it turns out not to be terribly efficacious. And in fact, we discovered only in the last 2 weeks, the UK recovery trial pulled the chloroquine arm because it was futility, it didn't work. And there have been another couple of studies in non-humans where it didn't work either. And we got we had our feedback from the medical regulators, the MHRA, the Medicines Healthcare Regulatory Authority in the UK, only on Friday, telling us that they would not be happy with us going ahead with a trial using chloroquine. So I've now spent the whole of the last few days, knowing this was happening, looking at this pathway again. And it turns out there are a whole series of other things we could be looking at. Remdesivir, of course, is one. But in fact, I'm not going to bore you, but I'm just going to give you a little clue. Things like, you're going to laugh at this. There's a food supplement. It's called zinc. Zinc turns out to have a really powerful antiviral activity, and it works just where the HIV drugs work. The only problem with zinc is you can't get it into the cells without a little trick, which I'm not going to tell you about. And if the trick works, then we will be able to use zinc. It turns out there are a whole load of other things here. So one of the problems for the virus is it has to sit inside these are called lysosomes, and the lysosomes have to be acidic for the virus to get out. If you give a patient omeprazole, I'm a gastroenterologist, I give omeprazole to everybody for their acid reflux, it actually makes these lysosomes more alkaline. And there might just be a possibility, I'm not sure how big the possibility is, there might just be a possibility that actually you could cause some interruption of the viral replication by giving people omeprazole. Do not, by the way, ladies and gentlemen, do not take anything I'm saying as things you should be using at home. That is nonsense. This is we're in the realms of thought experiments here, rather than in the realms of what can be used medically. But I can tell you, I have actually, with some very good friends of mine, colleagues internationally, have come up with 8 possible other medications, and we now need to test them very, very fast to see whether they're going to work, because of course the chloroquine thing has sadly died. And so I've shown you lots of pictures of different countries. The Crown Coronation group actually covers a whole load of countries. It covers Canada, the USA, Ireland, UK, Cameroon, Ghana, oh dear, what was that one? Senegal, sorry, that was Senegal, Ghana, Cameroon, Ghana. Oh, I'm not very good at this, am I? Kenya, Uganda, Zimbabwe, Zambia, South Africa. There, it wasn't too bad. And so we have a lot of countries involved in our collaborative, and Peru has also stated some interest in getting involved. And of course, South America is under really serious pressure at the moment, but actually so is Africa. And it's only just taking off there, and it's after they have given up with their lockdown, which augurs very badly for them. So, ladies and gentlemen, I'm going to stop there and let you come up with your questions, but I'm going to make a little plea. I've given you a hint that there are some really interesting things that we may be able to explore. And although we have funding for the trial, we do not have funding for these rather complicated but very quick studies we can do, which will cost us about £150,000, which is cheap, because we actually got 9 million to do the trial in 30,000 healthcare workers internationally. But that is ring-fenced for use in those people. If anybody would like to join our crowdsource funding, I will put the information on the chat. Ladies and gentlemen, that is all I'm going to say, and I'll be very happy to take any questions that anybody would like to ask me.
Wow, that Professor Lovat, tour de force comes to mind, both geographically and pictorially and scientifically. That was absolutely brilliant. And to be honest, I didn't want that to end. Really, really helpful. Really,
Sorry,
really.
The clock beat me. Clock beat me.
Yeah, no, you're good. We've got time. We've got time. Now, one question I noted. Let's just go back to a question I noted earlier from Mark. I don't know which Mark that is. It could be Mark Scheinfeld, possibly. I don't know. Is COVID-19 unique in attacking old? Which country is that? I don't recognise that tower behind you with that clock. What is that? I don't recognise.
Indeed. So it's not unique. One of the questions, of course, is why it affects older people more. And we know that the immune system is not quite as adaptive as people get older. We also know, and I mentioned to you these ACE2 receptors, there is a change in the quantity of ACE2 receptors as people get older, and that might actually increase the amount of viral entry into cells. We don't understand fully why older people are particularly at risk. And there are a whole series of hypotheses, but I've given you 2 for starters.
Lovely. A quick one from me, actually. Vitamin D and COVID.
Yeah. So vitamin D, there are data suggesting that vitamin D might be helpful. But again, there's no proper trials. And the answer, should you take vitamin D, the answer is pass. It's completely safe for the vast majority of people, so why not? On the other hand, if you've been in lockdown, done what I've done, right? Look, I'll just show you. I mean, hey, not often you get to see a bald pate with that much suntan on the top. My vitamin D levels are probably very high at the moment. So, I mean, that's not a joke. If you sit outside, you're going to get vitamin D. Whether you should take vitamin D supplementation, pass. It's not been adequately explored, but it's relatively unlikely to make a huge difference, because if you think about it, South Africa, you've got India, where it's going through the roof, I know you can say, well, the people are dark skinned and therefore they have less vitamin D, but there's so much sunlight there. And South America, where there are a lot of people who are not very dark skinned, and yet it's going through the roof. I think vitamin D alone is not going to be adequate.
Lovely. I saw David Lawson here asked, this is a geographical specific one. Is there any explanation for the apparent very low rate of infection in Thailand? I don't know if you know anything. Is there some research?
So I know about New Zealand and I know about Australia. I don't know anything about Thailand. I know there's a very low rate in Japan as well, but it seems, and so also in South Korea. I suspect Thailand has a similar thing. I haven't heard, but essentially they've done the dots. They've been really good at tracing, tracking, treating, not isolating. And if you do that, you can really keep your rates down.
Okay, there's a question here from Dr. Robert Shapira. That's Robert, as I know. Although the question will be whether I will actually be able to read it. If it was in Rabbinic Hebrew, I could do a good job. But please comment on the use of vitamin D prophylactically or given acutely IV with dexamethasone. Is that similar to my question?
Yes. Yes, I can't. So I have absolutely no idea about giving it intravenously. I have actually never seen an intravenous version of vitamin D, and I've certainly seen no studies on it. And I have to tell you, while I've been looking at the mechanisms of actions of other parts of the pathway, I have to admit that I have not looked in any detail at vitamin D, and I'm not sure why it is so successful. But I suspect the problem with circumstantial evidence is that it's no replacement for proper trials. You can look on the World Health Organization's list and you can check what trials are going on with vitamin D. Again, I haven't done it. It doesn't seem to me, there's a limited amount of time anybody's got, and a limited amount of energy and a limited amount of money, and you have to put your money where you think that the success is going to be. I think we're much likely to be successful on drugs which we know attack the viral replication phase inside the cells, or drugs that very specifically attack parts of the immune response. And vitamin D doesn't do it. It's going to be a general thing, and therefore I think it's not likely to be a big winner here.
I mean, it seems that we are very early. Part of this almost is that we're early in the pandemic.
Yes.
And there's so much, I mean, that's your graphs of the future trajectory placed it was so early. And I think that's quite hard for a lot of people to think how much more there is. It's not over in a month or two. This is a long haul. And the next two questions, I think, linked to that. Marilyn asked, can you really catch it again, or are they worried about a mutation? And then Deborah Lawrence Cohen asked, is the coronavirus getting weaker? Do we worry that the mutation of the second wave will be I think the Spanish flu, wasn't it, a stronger mutation?
But so they say.
Right.
So there was an enormous amount of work at the beginning looking at how much coronavirus was mutating, how quickly it was mutating, and it appears to be a very stable virus. It doesn't appear to be mutating very much at all, if at all. However, in the last week, there's been some reports about the possibility that it is getting weaker. It's too early to say whether those reports will be verified. But of course, as you pointed out, when it mutates, it can become much worse or it can become weaker. And one of the things that happens when a pandemic turns into an endemic thing is actually it may be that the virus mutates into a weaker form, which has a benefit to the virus, because the virus doesn't really want to kill its hosts. It wants to live with its host so that it can keep reproducing itself, not the viruses think. But that's sort of if you want to anthropomorphize your viruses. So it is better for a virus to be slightly weaker so that it can jump from person to person and keep going than being so strong that it kills the person who hosts it.
Connected to that, actually, I was reading this week some stuff. Actually, one of our members had put me noted some American physician, I think called Eric Topol, interestingly enough. I don't know if you ever...
I know. Eric Topol is very famous. He's a very important man.
Yeah, he has some fascinating threads that I mean, again, I'm not understanding all of that, but one of the interesting threads was about whether, do you get away with it by being asymptomatic, or is there actually, can the virus damage whatever, or at least in some way? In other words, and of course, can people who are asymptomatic, of course, be able to give the virus on,
Well, for sure they can give it on. And one of the things we don't yet know is what the late effects of the virus will be. So everybody will remember the film Awakenings, the people who had been in stupor for years and years and years, and then they were given these new Parkinsonian drugs, DOPA, and suddenly they all woke up and then they all became ill and slid back into their stupor. They had developed a post-Spanish flu encephalitis, and they were sadly vegetables for 40 years after the Spanish flu. We have no idea whether this particular virus will or won't cause any long-term illnesses past. I mean, some do, some don't. We'll have to wait and see.
A lot to daven for here, I think. Ellis Mandelson quickly asked if he had the virus, he was ill, tested positive, antibodies, pantoprazole,
Yeah.
hernia. Could that help him recover?
So my answer to you, Ellis, is maybe it did, and maybe it didn't. And the only way we can find out is to do a proper trial. And those trials, I'm afraid, are very expensive and they have to be done if we think it's worth it. Interestingly, there is another way. And Eric Topol, in fact, is one of the people who does this sort of stuff, looking at huge data sets, because we now have artificial intelligence and we have enormous data sets which we can access. You can actually start interrogating that. And some of the studies that are going on are looking at these very, very, very big data sets. This is all new. And we may get some new insights. I doubt the pantoprazole was a big part of the story, but I really can't tell. You know, one of the things I want to test is something like omeprazole or pantoprazole in one of the studies that I'm trying to set up.
So there obviously are other questions here as well, Laurence, relating to policy, which obviously is harder for you to get into, although nevertheless. So I noticed Judith and Johnny Morgan. Johnny was a wider one here about what his review on social distancing and its possible reduction. And I think Judith asked if this is just the beginning of many waves. Do you suggest we continue self-isolation as much as possible? In other words, it's just a really difficult balance between opening up and, as you said, the fear that opening up will lead to, you know, an increase in the R rate, etc. So I wonder what you want to say about that. In other words,
I want to quote to you. I want to quote to you. So Tana Rabbanim. So this is Baba Kama Samach Amud Bet. So it's page 60, side 2. Tana Rabbanim Deve Ba'ir Kanes Raglecha. When there is a plague in the city, bring in your feet. Just number, stay indoors. As the Pasuk says, don't go out from your house until the morning, until it's all clear. But there's also an opposite, and that is when the plague is out, you need to get out of the city. And so the question is, how can it be you get out of the city but you've got to stay indoors? And the answer is, get out of the city before it takes hold. And once it's taken hold, you've got to stay indoors. I personally am very uncomfortable about the idea of spending too much time with large groups of people. Clearly, you mustn't. There's a balancing act here. We've done a social experiment we've never done before. This is the first time humanity has ever done what we've done by locking ourselves down completely. There are going to be some horrible, unexpected side effects of it. The mental health thing is obviously a big one. Child abuse, big one. The lack of education for our children, I am appalled by what's going on personally, but these are personal views. You may disagree with me. But in terms of social distancing and possible reduction, if you're outdoors, 1 meter distance is much less dangerous than if you're indoors with 1 meter distance, because when you're outdoors, the air is flowing faster, and that means the virus, if it comes out of the person's mouth opposite you, will be more likely to disperse. So it's a balancing act. But would I recommend self-isolation as much as possible? Within limits, yes. Within limits, yes. We do need, as social beings, to socially interact. We mustn't cause ourselves to become, I mean, we already hear about children who are too frightened to go back to school. They've got to go back to school before term finishes. And you know, so it's a balancing act. There's no right or wrong answer to that. But I think in principle, we want to limit ourselves to small gatherings for the foreseeable future.
So that's interesting, actually, because there's been a lot of confusion around places of worship opening up. Initially, there was the idea that only individuals would be going in, and then, you know, multiple individuals, it would be a certain number. Now we're told it's however many your place of worship takes through social distancing. I was in my synagogue today with chalk and spray paint outside and etc. Is there anything you could say about that, you know, that process which we're now going through? Because what you're saying is, look, fine, you can go down, but actually you still want to be careful about how long you're spending with groups of people.
Remember, it's approximately 1,000 virus particles to get you infected. So if you and I are facing each other and we are very close, and I've got the virus and I breathe on you, it'll only take, each breath will give you 20 virus particles on average. If I sneeze on you, one sneeze will give you the whole 1,000. Okay? If I'm 2 meters away and I sneeze, you might not get your 1,000. Do you understand? If I have 2 sneezes and you're a meter away, well, actually, you probably will get your 1,000. And so it's about how much. So part of the thought process is not just about the distance people are away, but also things like airflow. If the air could be made to flow from behind everybody pushing forward, and if everybody was facing in one direction with their back to the airflow, so the air is coming from behind you going forward, and so the virus that I breathe out hits the back of the person in front of me, that's okay. They're not going to get infected because they've got to breathe it in to get infected. If on the other hand you've got people facing each other, or you've got, or they're too close to each other, or there's lots of touching of surfaces, and people spit on their hands, touch the surface, and the next person spits on their hands, touch the surface, and then licks it, you're going to get your 1,000 virus particles. So there's a degree of common sense, and there's also a degree of thought about how you sort out the social distancing. At the same time, it's really important that we don't all spend the rest of our lives as hermits in our houses, and we are pretty confident there will be people who will never go out again, who will become agoraphobic as a result of what we've done. And that is, the hidden costs. And one of the other hidden costs, I'm sure most people are aware of this already, but the number of people who came to casualty, to accident emergency, during March and April fell by 90%. But there was excess deaths of many tens of thousands, and we reckon that 1/3 of the excess deaths was not COVID related. It was related to all the other diseases that people didn't go to hospital because of the heart attacks and the strokes. That's a hidden cost. So it's very, very difficult. There's no right answer.
2 more questions here. And obviously, if anyone else has a question, we've probably got 1 or 2 more. We can please do put them in the chat. So 2 very simple ones here. I think you probably touched on them. Marilyn Grant, can you catch it again once you've had it? The famous question. Can you catch it again? But which of course.
So far there have been no recorded cases that I'm aware of that have been proven that somebody's caught it twice. There's certainly been stories of people who, it happened to some friends of ours. One of them got it, was quite ill, recovered, and then their spouse got it and was quite ill, and then the first one got ill again. And it may be that it hadn't quite cleared, and they got a further dose while they were still recovering. But the idea of being completely better and then becoming ill a second time has not yet been definitively proven. It might happen, and certainly one of the big worries is because the antibody response to coronaviruses tends not, the immune response overall tends not to be long lasting, which is why people, for example, have vaccinated against the flu every year. That's an influenza virus, but the coronavirus is similar. It might well be that people will get it a second time, but we just don't know yet. And I noticed that somebody's put in this thing about antibodies waning after 8 weeks. I mentioned that earlier, absolutely right. Antibody levels do wane, but we don't know whether the waning of the antibody levels means that the waning of the immunity, because immunity is not all through antibodies. There are a series of different pathways for immunity, and the other ones haven't been measured. So don't know. Really interesting, but we don't know.
Why is Jewish death rate so high? I suppose the question really is why is possibly, even though that might be the answer, but why was the Jewish death rate so high? In other words, was it contingent on Purim and Shabbos?
Correct. We seem to have, at the moment, our death rate appears to be twice as high as the general population, and there are probably 2 factors. One is that we're a jolly sociable lot, and it all happened just around Purim time, and where people, I remember in Purim, I was already not touching anybody and I was running off home, but there were plenty of people who took part in huge Purim Sudas and big parties, and I remember at the time thinking this is really not very wise, but people learn, and sometimes they learn the hard way. So yeah.
Do we know if the religious community was affected more, Laurence, in terms of
the answer to the question is I haven't seen the data, but my personal impression is that that's the case, because unfortunately I know quite a lot of people who died for various reasons, and it certainly appears to me that it was much more in the frum community than in the less frum community, the people who really engage in these highly social activities all the time. But I can't give you a chapter verse on that. That's certainly my impression.
Yeah, no, similarly. What's the issue with diabetes and COVID? Why is diabetes an issue that often is linked?
So the answer to the question is I actually don't know all the details, but in the immune response, people with diabetes have a poorer immune response. Generally, their immune system is not as good. And one of the things that may happen is that if the immunity, so there are multiple levels to immunity. There's innate immunity, and then there is an antibody-generated immunity, and then there is a humoral immunity, and then there is a second type of immunity that's run by T cells. And if the first type of immunity fails, the second one will kick in, but it's not as good. And one thing we think that happens is the first type of immunity doesn't quite work in some people, and the second immunity approach really kicks in a big way, as it does in many autoimmune diseases, of course, which diabetes is one. And that might be why they are more at risk, because their innate immunity is not as active. But I can't say hand on heart that's correct. I don't know.
Okay. So one last question, and I think that's I'm going to take the prerogative of the last question, which is obviously as someone who is of religious, a person of belief. Of course, many are. I mean, there's a discussion about religion and belief anyway, in the connection and etc. What reflections have you had at this time in terms of our, this is quite a time of reflection, this time of COVID, for many people more than they've had in their whole lives, because of our inability to feel the sense of control over how we can actually run our life. I wonder what how maybe to finish on some thoughts.
Okay, you might not like them, but I will share them with you. So the thing that really struck me is that we believe that we're in control, and when the writing is on the wall and it's absolutely barn door clear what's going to happen next week, people don't take heed. And that to me is a metaphor for something else that's going on in our lives right now that people are simply ignoring and at our peril. And that is climate change. Climate change is the single biggest risk to humanity. And I think HaKadosh Baruch Hu said to Adam Arishon, he said, you guard Garden of Eden, because if you don't, nobody else will. And I think if we learn anything from this pandemic, of course, one of the reasons that we have increasing numbers of pandemics is because of global warming, because of increasing numbers of people, because of deforestation, because animals are in closer contact with humans, all the globalization, all of those things. If we don't mend our ways, I personally think that the pandemic could be seen as a warning call for us to make huge changes to our lives, to save our children from the terrible, terrible scourge that global warming is likely to become. I told you it wasn't very jolly, but that's actually what I've been thinking.
It wasn't jolly, it was inspiring, no, because I think really, really inspiring, because and it's something we've worked as a community on. I know others have, and I think it's almost that there's a vindication, I'm sure, for many, but also I think it's almost I'm trying to think how to put it, a appropriate a connection to our emunah belief. In other words, there's an easy way to go, this is a punishment for something, an onesh, but actually here there's a clear connection as well between the nature of globalization and the root possible of the pandemic. So that's wonderful. Well, so what I'm going to do, Stephen Feldman, who was not able to make it tonight, usually unmutes everyone so we can all, that was absolutely phenomenal. I'm telling you, that really was. I'm going to exit full screen, go to that. I'm going to get rid of my chat. Sorry if anyone had a question I couldn't answer. Unmute everyone. You're all unmuted, so unmute yourself if you're not. And let's all give Professor Lovat a big, big...
Well done, Laurence.
I'll wish,
I'll take a bow.
You can